We're going to start the next lesson. This is section 2 in chapter 1. This is over solving literal equations. We've done a little tiny bit of this. So this is maybe the first, or I guess I should more say, we have not done any of this yet. So this is not part of our review. I guess we kind of did it because we took questions like this and put them in slope-intercept form, which is kind of the same idea. It is the same idea. The difference is we have some that are going to be different types of equations. So in the review that we did, they were all always standard form. I told you every single one you do the same way. You take your x to the other side, and then you divide the number with your y. So it's the same stuff. It's just they're going to look a little bit different for some of these. Some of them are going to look the same, but not all. So literal equations, the reason is the example I gave to the other class. Maybe this is not a good example. If it doesn't make sense, you don't need to know this. But if I gave you like 10 rectangles and I told you the area of every single rectangle and I told you the width, I would know what the length was. If you have to plug numbers in and solve the equation 10 times. The easier way to do it is to solve the equation first and then plug numbers in. So if you solve the equation for your length or whatever one I said, then you just multiply and do a quick division problem or something in your calculator. That way you're not solving a problem every time. Now again, if that doesn't make any sense or if that doesn't help you at all, that's totally fine. So basically what a literal equation is for our purposes, it's an equation that has more than one variable. And we're solving for different variables. So what we did before is we put this one in slope-intercept form, which means we're solving for y. So that's all we're doing today, we're just solving for a specific variable. So just like I said with the other ones, we need to get this 4x to the other side. But that 4x, since they're right next to each other, they're kind of stuck together. We want to try to keep those together and treat them like they're just one number until and to split them up. And the only time we actually have to split them up is if I'm solving for x. So I can keep them together. So I subtract 4x from both sides. I personally still put my variable first. You do not have to in this chapter. With slope-intercept form, I would definitely do that. But if you're just solving for y, whichever way is fine, and I'll show you that in a second. To each other, they're glued together. We're not trying to separate those unless we have to. Same thing with the 8 and the y. They're stuck together. They're glued together. We're trying not to separate those if we have to. However, with this one, we do have to separate because it's solving for y. Slope-intercept form is solving for y. So I leave them together until the very end, and at the very end, then I divide by 8. And I divide everything by 8. Equal to -4 is -half x, 24 over 3. Now, I will say with this chapter, you could solve it this way real quick. When you divide by 8, you could divide the whole thing by 8. There's times that you do that and it works out really nice and looks really good. There's other times that it's not really super convenient because technically you could reduce the 4 and the 24. So for my personal preferences, and I'll talk more about this later, I do it the same way. As much as I can, I try to teach you how to do it the same way every time, even if it might look a little bit not as cleaned up. Because I think as soon as you do the same way and I tell you a different way, I think it's confusing. So yes, for some of these, if you want to do it over one big fraction, you can do that. Because I think that's a lot easier to reduce. And again, if we are putting in slope-intercept form, then you do need to put in 2 separate ones. We've already done. Now, moving on to number 1 and 2, notice how number 1 and 2, they're the exact same equation, just one of them is solving for x, one of them is solving for y. That's the only difference. One, you're trying to get a by itself. So number 1, we're not getting the y by itself this time. We're getting the x, so I need to get rid of that y, just like we did before. X is still there. Then I do -4y plus 12. And if you put 3x is equal to 12 minus 4y, again, that's actually fine. That's perfect. I don't like to do it that way because I always like to keep my variable first. Because we do slope-intercept form our variables first. But again, you don't have to. I just try to stay consistent. I think that helps people. Then, just like the last grade of 3 in the X that I had to, just quick. Because I'm solving for X. So I go through, I divide everything by 3. I like that better, like I said. So my X is -4 over 3y plus 4. Now again, there are several other ways to write this answer. You can put the y up here with the numerator, so it's -4y, all of that over 3. That's fine, that's the same thing. Again, a lot of these answers, there's a couple different ways to write them. I'm not finicky on which way you write them. I just try to stay consistent. Purpose where number 1 and number 2 are the exact same equation, you're just solving for different ones, because I want to make sure you see what those differences are. I want to make sure you see. Now I'm just solving. That's the lunch bell. Okay. Go to lunch. We'll finish when we come back. All right. We're going to keep on going with. So the next one we're solving for y. Again, essentially it's putting in, but this is asking, I guess, a different way. Done this a bunch. From both sides. Now again, I personally, I know it's not telling you to put in slope-intercept form, but I like to put the x or the variable first, just because then it's the same as what we've always done. So -3x and the 12 is positive, so plus 12. Make sure you're not adding those together. As I'm grading some tests, I do see some people that take 12 minus 3 and say that that's like -9x or something crazy. Then from here, divide everything by 4. You end up with y is equal to -3 over 4x plus 12 over 4 is 3. And I know some people that will do -3x plus 12, they'll put all of it over 4. If you leave it like that, I'm fine with that. I've talked with people before that don't count off for that, because technically you can reduce the 12 and the 4 like we did over here. But again, for me, I'm not that particular. I would just do it this way anyways, because it's, I mean, again, it's easier to see where you reduce. But we'll get to one sometime, I think. It might look a little bit more clean like that. But like I said, I'm always going to do where I divide both of those terms or all the terms. Okay, so moving on. We're having some problems that are a little bit different than we had before. Now, honestly, in my opinion, this is one of the bummers about literal equations. So like we had before, I would give you a question in standard form. So it always started the same way. We had our x, our y is equal to the constant, every single one. And we put them in slope-intercept form, so they all ended the same way. So you had the same starting point and ending point, so you did all of them. The problem is, I literally, there's no way, and I'll try to do it where the questions you have on your quiz or your test, we've had examples on homework or on the notes, but there's an infinite amount of examples I can do where I throw stuff up, and each one's a little bit different. So this is one of the things that I've told you guys before that, like, it's not really a lot of math, it's more memorization. This is not memorization. This is a lot of math and understanding the concept, because you can't just memorize necessarily. I mean, I guess maybe you kind of can if you want to look at it that way. But you can't just memorize every single problem, because there's a bunch of different problems. You have to understand why we're doing things in the concept with those. So moving on, number 3 is equal to f. We're solving that for c. So c is right here. Make sure you know which one you're solving for. We will do fractions on Wednesday. The whole lesson is solving where we have different fractions. And so one thing we'll learn, if we have fractions, personally, I get rid of them right away. There's a couple other ways you can do it, and there's other ways you can think about it. You're dividing by 3. Either way, we need to multiply by 3 to get rid of that. Multiply by 3 is kind of the bottom. It cancels on top and bottom. A lot of people make the mistake where they cancel the bottom and they still keep the 3, so they have 3ac. Make sure you remember, it cancels the top and the bottom. Other people really clicks in their brain. 3 times f is just 3f. That's it. And some people like this because you don't have to think about it. You don't have to do 3 times 12, 3 times 24. You have to think about it. 3f is just 3f. 3 times f. C by itself, we have a multiplied by c. So to get rid of the a, we have to divide both sides by a. Keep in mind, when you divide this one by a, you don't divide each of these because it's not adding or subtracting. There's not 2 terms here. There's 1 term. 3f is 1 term. Divided by a, that cancels. We end up with c is equal to 3f over a. Obviously, there's a couple different ways to do that. I think that's the easiest way to look at it. Could be wrong, but in my opinion, that's the case. How's that? Any questions on so far? Moving on to the next one. The next one, and you don't actually need to know this, but this is the triangle. Most of you guys probably do. But the area is 1/2 base times height. And we were solving that for the base, the b. So now again, if you didn't know that the b stood for base, that's totally fine. You don't need to know that. I have 1/2 in front. Personally, I don't like fractions, and so I'm going to get rid of those fractions. So 1/2, I'm going to multiply the whole thing by 2 to get rid of that denominator. So I'm going to multiply the a by 2, both sides by 2. 2 times a is just 2a. A little bit, get some practice. It's actually 2a. You don't have to use it. Maybe it's because I'm terrible at mental math. 1. We still have the b. B all by itself, then both sides by h. It cancels. Obviously, doesn't matter if you put the b first or second. Those both mean the same thing. B is equal to 2a over h. Again, this would be a good example of why we do this. If I gave you 10 triangles and you had to plug numbers in and then solve, so you had to plug in a 10 for this a and then a 2 and then solve it all, get b every time, it would take 1. Now that we have this, all we have to do is sub the 12 to the 2 for the a and the h, and you calculate the problem. Wouldn't have to do any solving for it. Now, number 5 is an interesting one, and there's a couple different shortcuts depending on how you look at this, but this is what I'm going to tell you guys to do with it. I'll tell you how to do it. On mistake. So before I do this one, hopefully, and don't write this part down, hopefully you guys all know that if I have 2 times 3 times 4, that's the same thing as if I had 2 times 4 times 3. Doesn't matter. With multiplication, the order doesn't matter at all. So the reason I say that is personally, if I were you guys, the first thing I would do if I'm solving for w, I'm going to put that w in the back, just like normally when we solve for x, we got like 3x and the variables in the back. That's what we're going to do with this one. So I'm going to put this one as b is equal to L times h times w. Put that w in the back. FYI, you do not have to make your L's cursive. I just L's look for ones. I'm just kidding. So once we have that, now it makes it look a little nicer. Where for me, we're talking about like the 3x, we said they're multiplied, so they're stuck together. They're kind of, we try to keep them together. Same thing, the L, H, and W, those are all stuck together. They're all concrete, but we have to split up because we're solving for that. But the L and the H, we can treat that just like one number. We stick those together, we keep those together. So I'm just going to divide both sides. LH equal to B over LH. That's your answer. That's all by itself. That's the easiest way to do it. It's sticking with the same thing. Where if you're multiplying, if the letters or the numbers and letters are right next to each other, they're stuck together, and we try to keep them together as one item. Do this, which is still correct, is if you have B is equal to LW times H. Now, obviously, you could do it right. You wouldn't have to change the order. You could just divide by LH. That's fine.
You don't have to so you can still. But the other way to do this is 2 different steps, and that's fine. It's just a little bit confusing, and here's why. Divide both sides by L. That part totally makes sense. We have B over L is equal to WH. But now a lot of people, when they get to this point, they divide both sides by H. And so they have B H. That's not how you're going to do this one. Instead, that we already divided by L, so when we divide by H, that H just goes down with the division. It's the same thing. We will not do complex fractions. We're fractions inside of fractions. We won't do that until like next semester. It's terrible. If you have something to look forward to. Merry Christmas. But if you remember that, then yes, you do the same thing. You got the exact same answer. Either of those are fine, but that's the common mistake where a lot of people don't know what to do since that W is in the middle, and it's hard for them to wrap their mind around dividing by LH when the L and the H are right next to each other. So that's what a lot of people miss, and that's why I think it's kind of nice just to move that W out of the way, and then it kind of makes a little bit more sense to what we're doing. I try to stress, I certainly am not the guy who's going to make you do it the same way I do it. Just make sure you're showing your work so I can tell. And number 6, same thing with this one. We're solving for M. So again, we are dividing by A, or it's a fraction, whichever way you want to look at it. So multiply both sides by A. It doesn't matter if you put AZ or ZA. Doesn't make any difference. I'm going to put ZA. ZA. Now we have M plus B is equal to ZA. And I'm solving for M, so I need to get rid of that B. Well, now, since it's adding, you subtract. That cancels. Now, again, I'm going to make it as ZA minus B. You can make it negative B plus ZA. It literally makes no difference. And again, the ZA, you can make a lot of different ways to write this. Any questions on those? So I would highly recommend. So the thing with this, and I've said this before, if some of you guys are just super good math students, then you guys can do whatever risk you want to do. If you don't want to do whatever, it's up to you. Really try to make sure you do well in this class. The problem with these literal equations is, like I said, every one is different, and I can't just give you the same way to do every single one of them. So this is definitely an example. You need to get practice doing this. So if you're going to be one of those people that completely fix these next 4 you do problems and worksheet, skip the you do problems, skip the worksheet, and you get pictures from somebody else or whatever for the exit ticket or the homework check, that's on you. But I highly recommend not doing that because, again, every question is a little bit different, and there's about 10 ways to do it, about 10 ways to write each question. So do these next. Highly recommended. I'll put up the answers here in a second. So those are my answers for those problems on the you do section. Again, check over those. Make sure that. Again, this is one of those things that some of you guys really can wrap your mind around it, and you're pretty decent at it, but it's still kind of confusing. There's a lot of different things and a lot of different scenarios that can happen. Like I said, I try to give you the most likely ones, and I try not to use anything on a test or a quiz that you've never seen at all before. But I can't always guarantee that. If you have any questions, let me know. Make sure you are not forgetting to do your homework check.